Welcome to The Explainer. Today, we're going to put AI to a stress test. We've all seen those headlines about AI mastering these incredibly complex tasks, but what happens when you stop giving it a simple one-question quiz and instead you hand it the entire final exam? Well, the answer reveals a pretty critical flaw in how we measure AI intelligence.
Okay, so you see a number like this, right? Almost perfect. And we see them all the time. These eye-popping, near-perfect scores that make it seem like the latest AI models are basically geniuses.
And this 97% score, it's from a top-tier model, DeepSeek R1, on a really complex math benchmark. And, when you see a number that high, it's really easy to just assume, okay, that's it. AI has pretty much solved mathematical reasoning.
And that leads us to this huge assumption that we make about these large language models, or LLMs. We just figure they're natural multitaskers, that they can juggle a whole bunch of problems at once, kind of like we do.
But here's the thing. What if that whole assumption is built on a totally flawed test? What happens if we change the rules? Well, a group of researchers did exactly that. And let me tell you, what they found really challenges everything we thought we knew about how smart these AIs actually are.
So first up, we've got to talk about this myth of AI perfection. Because it turns out those incredible scores we just saw, well, they're based on a testing method that has some pretty big critical limitations.
See, right now, most benchmarks test these models on one isolated question at a time. But that's just not how the real world works, is it? I mean, we're constantly handling multiple streams of information. So this one question at a time approach, it just doesn't test how an AI performs under any real pressure.
So to get a better, more realistic picture of what's really going on under the hood, some researchers came up with a brand new way to test them. They call it REST, which stands for Reasoning Evaluation Through Simultaneous Testing. And the idea is honestly brilliantly simple. It's like, let's stop just testing the AI. Let's actually stress test it. So instead of a simple quiz, one question, one prompt, REST basically hands the AI the entire final exam all at once. It just strings a whole bunch of questions together into one massive prompt. And how it works is pretty straightforward. They take existing questions and just smash them together. The number of questions they use they call S, and that's the stress level. So a higher S means more stress. The model has to answer every single question all in one go. So, how'd the top models do? All right, this is where it gets really good. This is the moment of truth. What happens when you take one of these genius-level AIs, one that aces the single question quizzes, and you put it through the REST framework? Let's go back to that model from the beginning, DeepSeek R1. But this time, we're going to test it on a really, really tough set of problems from the AME math competition. Okay, so on its own, with single questions, it gets an amazing 81.7% accuracy. That's fantastic. But when you hit it with the REST stress test, asking it to solve multiple problems at once, its accuracy just absolutely plummets, all the way down to just 52.5%. I mean, that is a performance drop of nearly 30%. And just think about it. The only thing that changed was asking it to do more than one thing at a time. The difference is just staggering. And here's the crucial point. This wasn't a fluke. This happened across the board. The REST stress test is a much, much better way to differentiate between these models, revealing weaknesses that the standard tests completely miss. So why does this happen? Why do these supposed reasoning geniuses just fall apart under a little bit of pressure? Well, the researchers dug into the errors to figure it out. And they found a few common ways these things fail. Sometimes they'd get stuck in a loop, just repeating themselves over and over. Other times they would literally run out of brain space, what's called exceeding the token limit. But for the really top-tier models, two errors in particular stood out. And this is what's so fascinating. For a beast of a model like DeepSeek R1, the main problems weren't some weird technical glitch. Nope. The two biggest issues were just completely ignoring some of the questions, what the paper calls question omission, and then just making simple reasoning mistakes. Basically, the researchers figured out that the models get caught in this overthinking trap. They spend so much energy, so much of their processing power generating this super long, complex answer for the first problem that they literally have no mental bandwidth left for the rest of the exam. So is this all just bad news? Are AIs dumber than we thought? Well, not at all. The really cool thing about this research is that it doesn't just poke holes in our assumptions. It actually points us toward a solution for building more robust AI. See, it turns out some models are way more resilient to this kind of stress. Specifically, models trained with a clever technique called long to short. And just like the name says, it rewards them for finding the right answer using fewer, more efficient reasoning steps. It basically teaches them to be concise, and the difference is just night and day. Your standard models, they crumble under the pressure. But these long to short models, they keep their cool and their accuracy stays high. They're just far more resilient. You can see it so clearly here. As that stress level increases, watch what happens. The standard model's performance just nosedives. But the long to short model, it hangs in there, staying remarkably stable. And that right there is precisely why this research is so important.
Because at the end of the day, if we're going to build AI that we can truly rely on, as a co-pilot for our work or for other complex tasks, we need to test for more than just being book smart. We have to test for resilience. We need to know that when things get complicated, our AI co-pilot won't freeze at the controls.